This problem is concerned with two masses, an 8 kilogram mass and a 6 kilogram mass, initially at rest on a rough horizontal surface. The coefficient of friction of the rough surface is 1/3, and the two masses are connected by a light inextensible string, which means that this string has no weight and will not stretch when there is tension in the string, which will be caused by the motion of the two particles acted upon by a force of 60 newtons at an angle of 45 degrees to the horizontal. The tasks required are to calculate the acceleration of the masses, which will be the same as they are connected by the light inextensible string, and also to calculate the tension in the string. The first thing to do with this type of problem is to put on the diagram all the forces that are acting and also the forces that are required for the 8 kilogram mass and the 6 kilogram mass. First of all, would be required to resolve the 60 newtons into a horizontal component of 60 cos 45 degrees. It is cos 45 degrees because you have the adjacent and the hypotenuse, and the vertical component is 60 sine 45 because you have the opposite and the hypotenuse. The next force to consider is the weight of the 8 kilogram mass, which will act vertically downwards, and weight is given by mass times gravity. So the weight of the 8 kilogram mass is 8g. Acting vertically upwards is the normal reaction of the rough surface on the 8 kilogram mass, and this is given by R1. Because the 8 kilogram mass is going to the right, the frictional force always opposes the direction of motion. So the frictional force on the 8 kilogram mass will be going to the left and is denoted by F1. The last remaining force acting on the 8 kilogram mass is T, which is the tension created in the string. The direction of the tension for the 8 kilogram mass will be in the opposite direction to the direction in which it is travelling. So this arrow needs to be pointing to the left. Similarly, for the 6 kilogram mass, the weight is acting vertically downwards, which is 6g, and the normal reaction acting vertically upwards is R2. Since the 6 kilogram mass is also moving to the right, the frictional force acting upon it will move to the left and is denoted by F2. Once you have all these forces on the diagram, the solution can now be created. I will now go through the solution with you to show you how you format the solution. For the 8 kilogram mass, you need to resolve vertically. This is a double arrow because the 8 kilogram mass is not moving vertically upwards or downwards. To create the equation for resolving vertically, you need to look at the forces that are going vertically upwards and vertically downwards. The forces that are going vertically upwards are 60 sine 45 and R1, and the force that is acting vertically downwards on the 8 kilogram mass is 8g. Rearranging this equation to make R1 the subject gives this. Substituting G as 9.8, the normal reaction acting on the 8 kilogram mass is 35.97 newtons. Now we have found R1, we can find the frictional force acting upon the 8 kilogram mass, which is F1. Using this equation here, frictional force equals mu, the coefficient of friction of the surface, which in this case is 1/3, times the normal reaction. Therefore F1 equals 1/3 times R1, which gives the frictional force acting upon the 8 kilogram mass of 11.99 newtons. Now resolving horizontally to the right for the 8 kilogram mass, the only force acting to the right on the 8 kilogram mass is 60 cos 45, and in the opposite direction, which means to take away, F1 and T. The left hand side will be the resultant force acting in the direction of motion, which is to the right, and applying resultant force equals mass times acceleration gives the right hand side as 8a. Substituting F1 as 11.99, the equation then becomes 30.44 minus T equals 8a. Now for the 6 kilogram mass, resolving vertically, there are only two vertical forces acting on the 6 kilogram mass, these being R2 and 6G. Again, using the equation F equals mu R, we can then work out the frictional force acting upon the 6 kilogram mass, which is F2 equals mu 1/3 times R2. Again, substituting G as 9.8 gives the frictional force acting upon the 6 kilogram mass as 19.6 newtons. Now resolving horizontally to the right for the 6 kilogram mass, the only force acting to the right on the 6 kilogram mass is this tension here, and the force acting to the left on the 6 kilogram mass is F2. So resultant force acting upon the 6 kilogram mass to the right is T minus F2, and this must equal MA, which is then 6A. You have two equations here, you add the equations together, this T will cancel with that T to leave this, so the acceleration equals 10.84 divided by 14, which is 0.774 meters per second squared. From equation 2, by rearranging it, the tension in the string equals 6A plus 2G. Putting in the value of A here and the value of G as 9.8, the tension in the string works out to be 24.2 newtons.